Blockchain Mastery University. So this week I'm super excited to invite Nick here to educate us on a really important topic. That's going to be upgrading smart contracts, really designing your smart contracts so they can be upgraded when you're building Ethereum-based applications. So this is really important. Nick reached out to me because he's the author of the Diamond Standard that allows you to do that. So I'm super excited for the expert himself to be here to educate us on this topic today. So welcome, Nick.
Thank you.
Awesome.
Glad to be here.
Yeah, we're super excited to have you, man. So yeah, Nick, before we get into this topic, you're talking about upgrading smart contracts and designing them so that they work like this. Might tell us a little bit about your background?
Sure. I'm a Solidity developer. I've been doing contract development for a couple years. And yeah, I mean, and then before that, I was a software developer for a long time, writing software for manufacturers and stuff like that.
Yeah, very cool. And so it sounds like, Nick's been in the trenches, probably learning these lessons the hard way and innovating and trying to figure out what's the best way to build smart contract infrastructure to power these dApps, because we're all trying to figure that out as this is such a new technology, and we're excited that you've brought this forward.
Cool.
Yeah, totally, man. So let's kind of jump into the problem before we go to the solution, right? Because a lot of developers, when they jump into this space, they look at smart contracts and they think like, oh, great, this benefit of code that goes to blockchain and can't be changed. But in some cases, like that's a little bit of a problem depending on the type of application that you're building, right? Especially more complex applications that we're actually seeing in the wild that get a benefit of this transparency, but they do sort of trade off a little bit of the complete trustlessness that the contract won't change. Mm-hmm. So I guess before we jump into that, like maybe let's just drill down that point, because there's this pretty broad range of folks that we watch this video. Some people who are just brand new to programming, brand new to blockchain, and others who are a little farther down that path, all the way to people who are out there building their own projects, or working for a company, and they're trying to figure out like, hey, what are the patterns we can implement into our applications to make them more advanced and more industrial strength and robust, stuff like that. So yeah, maybe let's start back with that problem. But there's trade-offs. Let's talk about that a little bit, right? Whereas like a simple contract, like a basic token, for example, right? That might be something that is a set it and forget it. You put it out there and you don't really want it to ever change. It could be a single file Solidity contract, a simple ERC20 token, and you don't want developers to have really any ability to change that because it governs money, right?
Totally.
Yeah, totally. And so contrast that with these other applications that are being built, like, I don't know, let's say something like a compound finance or Aave or a decentralized exchange, like 1inch exchange or something like that, right? Where these don't necessarily have to be, these don't have to be applications that never change in any way, shape, or form, but they still have this huge added benefit of transparency, public verifiability, and all that kind of stuff, because they give you this benefit of being able to do settlement on the blockchain, right? And that seems to be like, we developers need to understand like what's the best way to build something like that. So am I warm here?
Yeah. So
yeah. Go ahead.
Okay, so yeah, let's talk about an example. So if you're going to build like an application could be a DeFi protocol like the ones you're talking about, or it could be a game, blockchain game, something like that. But what you're going to have is with typical development, when you're making something like making an application for users, is you're going to want them to test. When you build something, you're going to have testers, they're going to test things. You're going to get feedback from users and from people in your company, like this is good, this is bad. And from the result of what you learn, you're going to want to change your software, and that also applies with your DApp, with your DeFi protocol, with your game, and that includes your contracts. Especially in the development phase, you're going to want to make a lot of changes. And so where the diamond comes in, it comes in at this point, because since the beginning of Ethereum, the way that you would upgrade contracts would be this way you use something called a proxy contract, which would be one contract that basically points to another contract for its implementation. And the way you upgrade is you get rid of this implementation contract, you make your proxy point to a different contract. And so your proxy is pointing at A, and then okay, you make a change, so you make contract B, and then you point your proxy to contract B. And so that's how you would iterate your development and make changes over time.
Yeah, totally. And maybe I'll just clarify that really quickly, just so people can catch up before we kind of move on to that. So the whole idea here is like, let's say you create a smart contract for I'm going to use this example of like a project that we built in a program or something like that. So let's just say it's like a voting contract, right? It's got like two functions on it, one to like cast a ballot, and then one to like vote on that ballot. Okay. And so let's say you get that out there and you realize you need to make some sort of code change. Well, one common way to do that, what you're talking about, Nick, is like the proxy pattern, where basically you create a smart contract that implements those two functions, and then it says like, but all that contract does is it points to a different smart contract that actually implements all the business logic for those two functions. So if you want to make any changes, the proxy or the smart contract that implements the interface to those two functions never changes. The address stays the same all the time. But if you want to upgrade it, you can upgrade the internals that are in a different smart contract and then just change the address later, which, going back to our original thing, would not work well for a token necessarily, right? I mean, there's some tokens that work that way, but for these other DeFi protocols, maybe games, something like that, you're talking about this voting type of system that using as an example, the community might be okay with that, right? As long as people are using it and it's trusted, you get the benefit of transparency. But from a developer side, you get the ability to actually upgrade the contract and not have to change anything. Because I guess that's really important. Not because so many things that you're building these days are designed to be open protocols that other people depend upon. So you're not just talking about like, it's not just the pain of you, the developer, that builds a dApp with a user interface. Like you could always just like upgrade your smart contract to the backend and swap the address out on the user interface. But if you build a project that like all these other people are relying upon, you can't really just change the address of the entry point, because that is pretty obvious, right?
Yeah, that's right. You need a stable address is really valuable when you're developing something, so that you don't have to tell 1,000 people like, oh, we have a new address that you now have to use.
Right. Especially if they didn't make a way to upgrade their smart contracts.
Yeah,
So one implementation is what we just talked about, which is the proxy implementation. You can look at the Open Zeppelin library. Apparently has a good implementation for this. I was familiar with it before, but hadn't necessarily used Open Zeppelin's version. So if you want to check that out, check out the Open Zeppelin version. But what Nick is talking about and what he is the author of is the Diamond Standard, which is a different way of doing this from the proxy implementation. So yeah, tell us about the Diamond Standard, Nick.
Okay, yes. So the Diamond Standard is another way to create upgradable contracts. It has a little bit different approach than the proxy. I'd say that its advantage over the proxy is extensibility without limit. Because when you're implementing a system and you're making using a proxy contract and making changes over time, you might be adding more and more functionality to your proxy contract. But the thing is that a proxy contract is limited to the contract max size. the bytecode of a contract can only reach about 24 kilobytes, and then you won't be able to deploy it at that point. So what happens when you're developing your DeFi protocol and you reach a point where you need to add some functionality, but you can't because it's reached the max size. And at that point, you might have to refactor and think about, okay, well, I have to break up my proxy into like multiple other proxies that now do function calls between each other, which is going to cost more gas, and it's going to create more interaction with contracts that can be complicated. But the Diamond solves that. Diamond is a contract, but it's which can be upgraded, but it's unlimited in size. So you can keep extending it as you need, as your application grows. Your contract system can grow with your application needs. So
right. Yeah, totally.
Yeah, that's actually how it came to being. I myself was building a dApp called Mokins.io, and it was a non-fungible token app, and I implemented another standard called the composable non-fungible token standard, which is ERC 998. I know I'm getting to the weeds with this, but basically you have a non-fungible token that can own other non-fungible tokens, and it became quite a bit of amount of code, and it really belonged in one contract. But then I hit the max contract size, and I was like, oh no, and I needed a solution, and then I started researching ways to solve this. And the Diamond standard was a result of that a couple years later.
Nice. Yeah, that's very cool. And that seems to be how these things kind of transpire. Usually it's, you've got developers who are trying to, they're experiencing pain, building their own applications in the real world, and they implement something that works that they can abstract out into sort of a rinse and repeat strategy for other developers. And that's how we've seen the birth of a lot of, popular web frameworks and stuff like that over the years that have gotten a lot of adoption. So that's cool. Yeah. Cool. So, yeah, Nick, maybe we can look at some sort of concrete explanation of this. You mind sharing your screen a little bit to kind of give us a visual of what we're talking about?
Yeah, sure. It looks like it says that I need to, like, something on your end needs to allow me to.
Oh yeah, sorry. It's okay. Let's just see here more. Let's see here. Sorry, everybody. I think I just need to make. Let's see here. So there should be a way to do this in Zoom. I have this problem sometimes, but it's supposed to just work. Okay, tell you what, why don't you, if you wouldn't mind just pasting me that link in the chat, and I can share my screen, and we can kind of talk through it from there. Is that okay? Yeah, I have an issue with Zoom. I don't know why it keeps doing this. Okay. Sorry, everybody, for the delay here.
There's a link.
All right. All right, so I'm going to share my screen here. Let's do this one. All right, can you see that okay?
I see you good. Well, I see your calendar.
Oh, whoops. Let's stop that. Let's see here. I'm going to go back and edit this later, don't worry. Let's see here. All right, can you see the web browser now?
Yeah.
Awesome. All right, myself a little note here.
I kind of sent you a link directly to the diagram, but you can go wherever you want on that document. Yeah.
Okay, all right, okay, so jump back into it. All right, so here's a visual of what we're talking about here, Nick. And I've actually got this pulled on my screen, so I'm gonna kind of drive on the screen share, but I'll let Nick kind of give us a tour here, so you can point us to the important parts.
Okay, so how a diamond works is it has the ability to point to multiple other contracts for its functions, and these other contracts it points to are called faucets. And so this diagram here kind of shows the basic structure of a diamond, which is that when you call an external function on a diamond, well, then the diamond has a fallback function, and the fallback function has to find, well, okay, you call a function on me, now where do I find this function? Where is this function? And it gets this function from another contract, which is, as I said, a faucet. And so it has a mapping from function selector to faucet address. And so it uses this mapping to find, well, what's the faucet address to the faucet that has this function? And so this diagram shows that. It shows these different functions and their different addresses. And what happens is once it gets the faucet address, it goes ahead and calls the function on the faucet and returns the results. And so actually, can borrow the functions from faucets and execute them as if those functions existed on the diamond.
Right. Yeah, that makes sense. So I'm just gonna kind of sketch this out here really quickly. Can you see my whiteboard here?
Yeah.
So basically, like, if you're talking about, you have like a main contract. So this is like your, let's just say your game. Let's go with the example you said earlier, like voting contract, right? And it's got two functions. One that's like, propose ballots, and then one that's like vote, right? So these are just two functions. This is one smart contract. All right, and then this is a function number one, and then function number two. So what you're saying is, like, on this diamond standard, this voting contract, instead of being like a proxy contract we talked about earlier, this would be a diamond, right? Yeah, this is a diamond. And so the diamond implements a way for these functions to talk to another smart contract where the actual logic for proposing a ballot lives, right? So this is like some other contract over here. He calls it faucet, right?
Yeah.
So this is a separate smart contract that's a faucet. And so there's no real like permanent business logic inside this function. It just says, hey, look for the code to call a proposed ballot at this separate smart contract that's called a faucet. Is that right?
That's right.
Okay. And so same thing for vote. And so you can just extract this away, and it goes deeper and deeper and deeper, I'm assuming, as your app grows more complex. Is that right?
That's right. So like you might start out with just this, with one faucet, where those two functions are using that one faucet, but then you realize, oh no, our voting, it needs to unvote, or it needs something else. So then you just add another faucet to it so that they can handle those new functions.
Right. Yeah, totally. So are you able to add more functions to the diamond as well?
Yeah, that's what I'm saying. Yeah,
Gotcha,
exactly.
gotcha.
You added the functions to the diamond. Yeah.
Yeah, very cool. That's great. Which I think we were chatting earlier that you call that out as a limitation of the proxy implementation. I guess it's what diamond solves.
Yeah, that's right. So yeah, so what Greg is saying that with a proxy, if you want to upgrade, you have to throw away your entire implementation contract and you have to deploy a new implementation contract that includes everything the old one had, and then in addition to your change.
Right.
Whereas with a diamond, when you do an upgrade, you only add just the part that you want, or you only remove just what you want to remove. You're not uploading all your functionality again.
Right. So maybe is there a code example that would just give us a little bit of visual reference on this page as well?
Yeah. I think
right here.
If you scroll up actually.
Okay.
There's a diamond has a fallback function. Let's see. No, go up a little bit more. Let's look at the fallback right there. So this is a fallback in a diamond, and so you'll see that there's that selector to faucet mapping, so that it looks up the message sig is the function that's being called, and we use that to find out what's the faucet address.
Yeah, totally. So I think you mentioned to me there was a sort of open source sort of template that people could reference in order to implement something like this. Do you have mind for that?
Yes, I do. I'll send it to you in a second.
And the reason I bring this up is because the benefit of this is it is rinse and repeat. Like once you have the ability to implement a diamond that points to other functions, you don't necessarily have to be able to implement this yourself. Like it's a solved problem in a sense. I'm assuming that right?
Yeah, that's exactly right. Is like this there's a fallback function that's written for a diamond, and everyone you just use the same fallback function for every diamond. So it's the boilerplate is just reusable, so you don't have to deal with it or mess with it. Just use it.
Yeah, very cool. All right, so I'm gonna pull that link up here. I'm gonna have to kill my screen share for 1 second to get the chat, but I'll start back up. So yeah, I think the one reason that's really important is A, it doesn't make sense to reinvent the wheel if you don't have to. And B, I think it's really helpful because, I noticed when we're looking at this that it contains like some inline assembly and things like that. And that's something that, especially more beginner developers are going to kind of freak out about a little bit. And honestly, like a lot of people who are just kind of building run-of-the-mill stuff wouldn't necessarily need to understand that level of detail inside the contract itself, which it's good if you can just use somebody else's implementation to do that. Let's see here. So I'm going to share the screen again. All right, so here we go. So can you see my screen okay, Nick?
Yep.
Awesome. So is it in the contracts structure here?
Yep.
So diamond.sol?
Yep.
Cool. So this is the template that we're talking about here. So if you want to give us a quick tour, does this implement that fallback function that we just looked at right here?
Yep, there it is.
Awesome.
Yep.
So I'll put a link to this down in the resources. So this is where you can find the implementation to implement it inside your own contract. So let's see here. So here's the fallback function. And then here is the constructor. So what does the constructor do again?
Yeah, so it's common in a diamond for a constructor to add the initial faucets that you want for the diamond. Because the diamond points to these different faucets, so it makes sense that when you first create a diamond, maybe there's a few faucets you want to have at the beginning. So the constructor, you can see that we have like a diamond faucet, diamond loop faucet, ownership. So these are faucets that are being deployed and then added to the diamond, so that when the diamond's first created, it has these three faucets from the beginning.
Right. Yeah. Totally. Okay. So I'm looking at this fallback function again. Faucet. So tell me a little bit about how this fallback works, because I'm thinking of fallback in terms of a function that you have implemented inside your contract, basically in case it receives ether. You know what I mean? But in this case, you can think about it, I guess, in receiving any kind of message. Is that right?
That's right. So that's right. A fallback, anytime you call an external function on a contract and the contract doesn't have that function, then its fallback will execute if it has a fallback.
Right. So basically, so I'll clarify what I was just talking about in case anybody's not familiar. A lot of times it's common on a smart contract, especially if you're expecting ether to be sent around to implement a fallback function that basically just says revert. Because the common use case there is somebody tries to send some cryptocurrency to a smart contract, and then the contract receives it and they can't get it back. So what you can, but that is in case you don't implement basically a function to handle payment to the contract. But in this case, what we're talking about is the fallback function will fire if the function that you're trying to call is not implemented. And so that frees you up to implement any kind of function that you want. And then inside the fallback, basically you can route that function call to whatever faucet you want inside the diamond. Is that right?
Exactly right.
Okay, perfect. Okay. So yeah, so somebody wanted to, customize this. Would they need to, and they didn't want to use these exact diamonds, it's just they would take out some of these, like adding the ERC 13, sorry, am I reading that right? 173 functions, something like that?
Oh yeah, so a person could, this is totally customizable, so a person could, change what faucets they add in the constructor, remove what faucets are added, or add more faucets. This is just like it's sort of a template with slash example. So like, there's things that you'll always kind of want to reuse, like that fallback function is standard for every diamond, but the constructor here is really just an example.
Gotcha.
You can, add or remove what you want.
Gotcha. Okay, yeah, very cool. And so I guess, good.
No, there's a couple other things I might mention, and that's and you mentioned this earlier, that transparency is important. Like when you have a contract, it's good to be able to access its source code to know what functions does this contract have, what is this contract doing, so I know that, so that's me or an expert or someone can look at it and know it's not doing anything that's not good.
Right.
And so the diamond standard actually specifies things to make a diamond transparent. And it specifies 4 functions, and these 4 functions are you call these functions on a diamond, and those functions return to you what faucets is a diamond using and what functions from those faucets. So you'll return the faucet addresses and what functions. So that enables tooling to query a diamond so that it can then get the full source code that's being used by that diamond, so people can inspect that.
Gotcha. So it's a standard interface, like any other ERC interface or something like that has to implement those functions, and that basically improves the transparency. I guess I could see you could do that. You could have some sort of like sneaky function that you don't even know is on there, right? You wouldn't even know where to look for it unless you were able to maybe look through the history of the transactions that were, being called whenever you sent the contract.
That's exactly right. Yeah.
Yeah. Very cool. Awesome. Okay.
And then there's so there's these 4 functions for transparency, and then there's another function called diamond cut, and that is for it's a standard function for adding or removing or replacing functions and faucets to a diamond. It's so this function is standardized so that tools can be used to add things to diamonds, and then it'll be one diamond can be compatible with many different tools because they all follow the standard how it works.
Right. Okay. Yeah. Very cool. So let me ask you a few questions about this. So also, I'll put a link down. This is Nick's personal repository with this, and I guess that's also put a link to this. This is the EIP that goes over this on a high level in detail. So I'm going to ask a couple questions about this. So earlier, you mentioned that you mentioned the problem of the proxy implementation, where basically essentially we're wrapping other functions like inline, right? Basically, you're saying like call this function, then call this function over here, with some extra machinery built around it. And that can get expensive in gas depending on how you implement it. So your proposition is that the diamond standard is more gas efficient per function call. Is that right?
Well, what it is the diamond, or compared to a proxy contract, like calling a function on a diamond is the same amount of gas as calling a function on a proxy contract. So that's comparable. But where there's possible gas, there's actually multiple possible gas savings with a diamond standard. But I think what you're getting at, one of them is that because a diamond doesn't run into the max contract size, you're free to add additional functions, external functions to a diamond for particular use cases in order to save gas. And a typical example of this is batch transfers of something.
Gotcha. Yeah, that makes perfect sense. Okay. Yeah, very cool. So is this a standard that, so you mentioned other projects that you had worked on that were sort of the impetus for this. Is this something that you've implemented in production right now that other people have also tried to pick up on?
Yeah, so I myself haven't implemented the diamond standard in production yet, but I'm working on that. I'm the contract developer for a project called Upgradable, and that's going to be using a diamond. So so that's exciting. There's another project that is in production using the diamond. It's called I forget what it's called, but I can send it to you.
Sure.
The diamond standard is really a creation based on another standard called EIP 1538, and it's called the Transparent Contract Standard, which is basically is the same thing as the diamond standard, but the diamond standard has some technical differences. The diamond standard is better than this older standard. I developed this older standard a couple years ago, and I did use that in production, and some people. So the diamond standard, is the work of the diamond standard is built off of experience and this prior standard that occurred.
Right. Yeah. Totally. So this is basically an iteration off of something that is already being used, but this one is an improvement. It's right. Soon to be battle tested in production.
Yeah. Very cool. We were looking at the diamond implementation there, and it's actually under a smart contract audit by Trail Bits right now. So
yeah. Very cool. Yeah, they're certainly important name in the space. I'm sure they're really busy right now too. Yeah, cool, man. We'll tell you what, Nick, is there anything else about this that we might have overlooked? I mean, I think you talked about the gas. That was definitely a question that I had. Maybe can you think of any other maybe trade-offs that or compromises that you might need to know about before you choose this for your own project? It's like, well, it does trade off this, but you get all the benefits. Can you think of anything like that?
Well, I could say that it depends on the application you're building. If you know, for example, that if you're going to implement a system that's never going to change and that doesn't require very much code, then just a contract that's not a proxy, not a diamond, just a regular contract, like you're saying, like a simple token, that'll be simpler and easier. In that case, a diamond, adds a bit more complexity, some more complexity. So if you have a system is going to grow and could change, a diamond is good. I should say though that there's different configurations with the diamonds. Like one scenario I envision is that you have a project that maybe you're developing over time, and you put it on a test network, and you have users testing and beta users, and then you're making changes. Using the diamond, it's really easy to just upgrade your diamond to make the changes, and that's going good. And then, but that when, for example, when you launch on mainnet, you want it to be all immutable, like it can't be upgraded. And the cool thing with the diamond is that you can develop it with it and make all the upgrades, but then you can also make it immutable, and it's easy to create a new version of the diamond that's completely immutable, so that you can have it upgradable until you don't want it to be upgradable. And it's easy to switch between the two. Okay. And so that's another interesting aspect.
So how does that work? You basically is it like burning an admin key, or does it like transpile it to something else? Like how do you relinquish upgrade privileges?
Right. So the diamond has a standard function, it's the diamond cut, that's used to add replace, remove functions. And so diamond cut can come from its own faucet. And so to remove upgradability, you just remove the faucet that has the diamond. You just remove the diamond cut function from the diamond. Now it can't upgrade anymore because that function used for upgrading is gone.
I gotcha. And so is that something that can be verified by the end user? I'm assuming they're technically competent.
Absolutely, because for example, the four transparency functions use that. Like one of the functions will return to you all the functions that exist in the contract or all the faucets. So you can look at the source code of all the faucets. So you can verify. Yeah.
Awesome. Yeah. Well, that's awesome, Nick. So yeah, everybody definitely check this out. I'll put some links down below. Like I said, this is a really important thing if you want to build, your own real world blockchain applications that, use Ethereum smart contracts, because, if you're moving beyond just building something like a simple token, for example, that you don't want to change, but you want this, a more industrial strength application that's realistically going to require some changes, but still has the benefit of transparency, still has the benefit of like fast settlement on the blockchain, all that kind of stuff. And this is a really good thing for you all to check out for sure.
Cool. And then there's another thing I want to mention, which is it might seem like this idea of having like one big contract with like all this code might be hard to maintain or something. Well, one thing I found is that because a diamond actually uses lots of different faucets, it makes sense to put related code in each faucet. Right. So with the diamond, you can still have your code that's organized in a nice way, even though it's like you have one big one address with tons of functionality. Your code is still organized into separate units.
Right. We need standards like that, especially with Solidity development, because it's also new. And if you're coming from another software background, I mean, it's just like the solid principle and all these things where you want to group your code into some meaningful chunks that can be reused or at least organized. And this sounds like a really good way to do it.
Yeah, and I know we're about done, but we're just really introducing the diamond. There's actually like really on the tip of the iceberg. I could keep on talking about it. For example,
tip of the diamond.
The tip of the diamond here, because like you just mentioned reusability. So each faucet is deployed, and what that means is that when a faucet is deployed on a network, well, that faucet can actually be used by multiple diamonds. So these faucets become like these reusable chunks of code. And so that's like one aspect. Another aspect is you can have a faucet that can access and use particular storage in a diamond, and that's unique to that faucet, so it has its own storage space in a diamond. And then you can have another faucet that has its own unique storage space, so the storage won't clash between them. You can have a faucet that has a storage space and another faucet that accesses accesses the same storage space. So you have so that these two faucets can share the same data. And so it's like there's these various configurations and security considerations too. But I found that it seems to me that there's workable ways to have this functionality while having security too.
Yeah, yeah, it sounds like there's a world of new possibilities for that. That's awesome. Yeah, very cool. Well, yeah, it sounds, at the end of the day, you're talking about using this in production, and you guys are getting audited by trail of bits, all that kind of stuff, which is definitely something you want to do if you're gonna build an application, put it out there in the real world. We've seen some pretty fast and loose clones hit the market in the past few weeks, that's for sure. I definitely wouldn't recommend that. So this is good.
Thank you so much for having me and letting me discussing. This is great.
Yeah. So Nick and I will wrap up here offline here in a second, but I'm gonna go ahead and wrap up our broadcast for today. But yeah, Nick, thanks a bunch for coming and educating on this. I know I've certainly learned a lot, so thank you. And I hope that everybody else has benefited from this as well. There's people watching this who are just brand new to programming and just getting their head around some of this stuff. And this is gonna feel a little advanced probably for those folks, but it's something to think about because as you get down the road, you're gonna, especially if you jump into a working environment or something like that, they're gonna talk about this stuff. If we're building production applications with smart contracts, we need to figure out how to upgrade them. So don't worry if like some of this stuff a little bit over your head. That's okay. Think about it as like a primer. And if you're in that environment already, or you're trying to like take that next step to build your own app that's gonna be used in the real world, then you definitely want to check out something like this. So again, thanks a bunch, Nick. I'm glad we have an expert himself on to educate us about this today. So yeah, that's all I've got for today. And until next time, thanks for watching.